So with that, let's go ahead and begin this evening. We're a moment or two after 6 o'clock. I've spent a little bit of time in some Zoom meetings with some of you over the last few days. I'm pleased to do that, and I hope that it's been helpful for you. So what I want to do is, as always, is go ahead and begin by taking any lingering questions that you might have with respect to the problem sets that you're working on, assignments that you're trying to get in, and knowing that you've got through the rest of the evening to get them done. What questions might you have?
Rick, I have a question conceptualizing number 9 on the CAPM and in-class problems, the ICP.
Okay, well, let me bring that problem set up.
Okay.
I've got a few things available here already, but I don't think I had brought that one up on my screen yet. And then I'll share the screen with you. And it's using, did you say using CAPM and WAC?
Yeah, that okay. Is the ICP.
That's what I thought.
Yeah.
Very good. Bear with me just one moment. Okay, so number 9. So I think you should be able to see my solution set here. And it said, how can you reconcile the values you assigned preparatory to making an offer to invest in the firm versus the one you might now calculate? So I think we're contrasting a couple of things, right?
Yes.
And what items do you believe we're contrasting?
So the 20% return on investment that the buyer is coming up with a valuation of compared to our 9.4% WAC that we came up with, the 147 million compared to the 2 million.
Right. So we see that there, and I'm going to go back to the front page of this for a second. We see when we looked at this that we had, based upon the 20% discount rate, we had a calculated value of 22,163,000. And you didn't have to come up with that. It was given to you, of course. You could have come up with it given the cash flows and such, but I decided to be a nice guy for once and actually give you a number, okay, that was meaningful. So, and then we go further and suggest that, okay, you've come up with that valuation, or someone has, but there's an offer on the table for $20 million. That's what this cost represents here at 20 million in the middle of the screen. Okay, so I believe I was saying that based upon the 20% expected return, and remember that the expected return is a substitution for a discount rate, right? It just happens to be the discount rate that the potential investor might employ. The 20% rate of return, we have a calculated value of 22,163,000. There's an offer on the table for even less still, which would suggest that the investor is trying to get an even greater return than that 20%. And then we're going to then think about comparing that to what you did in number 8. Well, in number 8, you're using a different discount rate, of course, right? You're using the 9.4% that you have now calculated as the firm's WAC because you've answered number 8 from the perspective of the firm. So there's a couple of things here. One of which is that discount rate change, which was not trivial. We went from a 20% discount rate that was imposed on us by a would-be investor to a 9.4% discount rate, or our calculated WAC for the firm. And that leads us to a value of 147,869,498. So $148 million. So how might we reconcile the two different values that we've got here? Obviously, huge difference. What, $127 million difference, $128 million difference? So, Jason, which of those values do you suppose to be more realistic, and under what conditions?
I would say the 147 million, although it's much larger, I just feel that taking the approach we did seems it's more realistic.
Okay, I would tend to agree with you. Does anyone know why I would agree other than what Jason just said?
It's because when you calculate all of this model based on what the investor is asking for, it's ballooning. it's ballooning the cost of acquiring the investment necessary.
Yeah, so if the investor is looking for a 20% return, that means they are more heavily discounting the value of the company, which is why they only calculated a $23 million valuation, whereas the firm would calculate a 147. And in question number 7, I think we talk about how realistic it is to have a 20% discount rate in the face of a 9.4% weighted average cost of capital, which is the rigorously calculated capital cost of the firm's capital components. Well, here we now see this in stark black and white. It's one thing to say 20% versus 9.4%, but this comes very clearly into focus for us when we realize that the 20% begats a value of about $23 million, whereas this 9.4 begats a value of almost $150 million. This isn't a little bit of a change. This is huge. This is not the difference between bid and ask in a marketplace. This is the difference between an investor who wants a much larger return than is warranted based upon the company's capital costs. So that being the case, what might the investor have to bring to the table in order to cause this value of 147 or 148 to become more realistic for them?
Capital, money?
Well, they're bringing some money. I mean,
More than,
they'd have
connections and know-how.
Yeah, exactly. Connections and know-how. So even at a 20% discount rate, let's assume that the investor was going to bring connections and know-how to the table and wanted a 20% return. In order to receive it, the investor's going to have to pay a number much closer to what the firm would require, but the investor still wants a bigger rate. Well, how do we get to that bigger rate if we're subject to charging an amount or having a cost for this investment similar to what we would see here, upwards of 150? Well, as we go through tonight, we're going to be looking at forecasting performance. And so we're going to forecast this based upon some ratios that we'll establish, but we'll also think about what adjustments might need to be made. What increases in revenue might take place because of the know-how and the relationships. What decreases in input costs might take place such that we have an increased cash flow. There's a value here that if we applied a 20% rate, we could come up with a decent net present value, but it would cost the investor much more than the $20 million they want to put in. So can we get them the required rate of return if they put in more money? Well, certainly we can, but we're going to have to expand the net present value yet greater still, which means we're going to have to apply some growth to this company that isn't immediately obvious. And it's probably going to be growth that's going to be a function of the relationships, know-how, et cetera, of this new management team led by this new investor. Does that make sense? Half of a little bit, maybe?
yes.
Okay.
So it's not necessarily all about the money in a sense.
Well, it's going to become about the money, though. We're going to show before we're done with the evening that tiny adjustments in some of our forecast ratios can bring about huge value changes, and maybe somewhere inside of those changes is the key or the secret sauce as to how to get this investor who only wants to pay $20 million for this company to be willing to pay maybe more like $150 million and still be happy. Now, obviously, we're making the assumption the investor's got $150 million, right? Let's go back to our decision criteria. If the opening salvo is just way too high, then no one's going to come to the table, right? But if the investor has the money that they could pay $150, then they would. But how are they going to be able to get their 20% return? By having enough growth that their relationships and know-how bring to the table to have their growth and activity yield the return to them, not the cost of capital of the firm's capital components. We'll revisit this again. I think it'll be even clearer as we talk about it again before the evening's up, and clearer still if we visit it again in another week, which, as it turns out, I promise we will. Okay?
Yep. Thank you.
What other questions? Okay, well, let me move to a PowerPoint then. And
I have a question, sorry.
yes,
So I'm same, but on the question.
Solomon, you are muted. I'm going to unmute you. Okay, you're unmuted now. I couldn't hear your question.
Yeah, I was saying on the same assignment, question number 8, I'm getting totally different numbers. Like,
Okay.
so I wanted to like ask, so on PVDFC, I'm getting the right number, but after that, all 3 numbers are different than given.
Okay, so which numbers are you getting right? Are you getting the PVDCF correct at 35,674? Okay.
Yeah, I mean, it's slightly different. I'm getting 35,673,215.41.
Okay, so let's first talk about that difference, which difference doesn't bother me. It's trivial, and you'll understand why for a moment, or in a moment. So here, I believe that I'm calculating all of this based upon a calculated WACC. This shows here at 9.4%. And I think that's probably exactly the number you used, 9.4. Is that right?
Yeah.
Okay. So you didn't use a calculated WACC that has greater numeric fidelity that we could round to further decimal places out, did you? You just used exactly 9.4, right?
Yes, I used 9.4.
Okay. So if you actually look more deeply inside of my models, you'll see that it looks like 9.4 here, but in fact it's not, because this is a rounded value. And if you round it out, it's something more like 9.39678 or something along those lines. And
Yeah,
that's then the rate that I use.
Go back, like if I expand it, so my WACC is 9.3988.
Okay. So maybe mine then used the 9.4, and yours used the more accurate one. My point is, those kinds of rounding differences based upon how we presented things will bring about a big difference in value sometimes.
Okay.
And in your case, it wasn't a big difference here. It might have become a bigger difference here in the continuing value.
And in other 3.
Okay, so let's examine how you come up with a continuing value. What numbers do you use to come up with this 366.81.7?
The first one, present value, the 3673.
Nope, this one right here.
Oh, this one, yeah. Oh, I didn't get 360. I got 346. I mean, I can.
Okay, what did you use in the numerator of that equation?
I use my, what's my F1? So I use SCF 13, which is 18722.
Okay, so I know exactly, this is what I thought you did, Solomon, and this is a very common error on this. So for the continuing value, do we use the cash flow from the last year of our explicitly forecast period, or do we use the cash flow from the next year?
Oh.
Yeah, we use the cash flow from the next year, right? So if you have included year 13 in your discounted cash flows, and you have, in order for your number to be right, then going back and picking this cash flow up again is double counting the cash flow.
Oh.
And it messes up the continuation term. So you would actually need to use the cash flow from year 14. Well, in this case, how do we find the cash flow for year 14?
I mean, it's not given.
Well, not exactly. But what is given is a growth rate for our cash flows in years 1 through 13, and a growth rate for cash flows in year 14 plus. So if you
Yep.
take the cash flow in year 13 and expand it by multiplying it by 1 plus this 4% or 1.04, that would give you year 14's cash flow.
Now,
That's the number that it becomes the numerator for this equation.
so I asked, so my total, if I show you what my total equation is, so cash flow of 13 divided by 1 WACC minus my growth rate of period 14. Is that the correct way of doing it?
So you can either take cash flow from year 13 and times it by 1 plus the growth rate. Now all that's done is given us the cash flow for year 14. And now we need to divide that by the discount rate minus the growth rate.
Oh, okay.
So see if that works for you. And if not, then we can pick this back up again later on.
Yeah, I think I'm still not getting it. So
Okay.
this is the equation, so I'll write it.
So we'll pick this up later on then, and see where your errors coming. Why don't you go ahead and email your spreadsheet to me so I can look at this as we're speaking a little bit later.
So I have one question before we do the number 8 that we kind of discussed, the numbers coming out wrong.
Okay.
On the WACC. Where did the 0.72 come from at the very end? Because it's not 7.2%.
Oh, up here, excuse me. Okay. This, I believe, had a tax rate of 28%, if I remember. Let's go.
Yes.
So 1 minus 0.28 is 0.72. So
Okay,
this
that makes more
0.72
sense.
is 1 minus the tax rate.
Thanks. I literally was just banging my head against the table trying to figure that one out.
You know, and it never occurred to me that these last two terms, 0.072 and 0.72, look so similar for you to confuse those until you asked me about them, Solomon. But for the next class, I'm probably going to update this a little bit so that those don't look so similar.
And I think that's what was pushing me for a loop too. Because I was like, no, it has to equate to the 7.2 somewhere. And I'm like, it doesn't though. So
Yeah. That's 1 minus the tax rate. So I tried in these parentheses to represent weight, cost, 1 minus tax.
okay, that makes sense now. I had it all down except for that one portion of it.
Certainly.
And then I also, like Solomon, I'm getting different numbers in my number 8. So on number 8,
Yeah.
the same thing. My numbers are off just slightly, but they're off. So my PV FCF, when I put the equation in for like year 1 is 4585743 instead of, sorry, scroll down to
Okay.
4570445.
Okay, so let me bring up my spreadsheet on this. Bear with me just a moment. So, okay. So in my outcomes, we're looking at the result of having a very finely tuned WACC that actually is a much different number than 0.094. It's 0.093985, blah, blah, blah. Okay? So if I simply typed in 0.094, my values are going to all change a little bit. Okay? So I'm going to guess, Heather, somewhere you have an original input value where I have a calculated value. And it may be in WACC or it may be in some of the components to WACC. It's somewhere such that it's affecting our WACC slightly. And that's motivating a change in these discounted WACC or discounted cash flows. So it motivates change in the present value of the sum of the discounted cash flows. It's going to motivate a change in this value as well, right? Because WACC, or discount rate, is being used there.
Yeah. And I typed everything in myself on the thing because I couldn't find I don't know if you had one, but I just made this myself.
So when you type them in, do you type in the equation or you type in the values?
So I've tried both ways actually.
Okay.
So I did the equation on the bottom part after the first year, like your example you did with the video. I did it just like that video.
Yep.
So in the WACC, I've tried typing in the 0.0940, it still doesn't work. So then I tried making it equal my WACC and it still doesn't work.
Okay. Well, so here's what I would suggest. if the outcome difference is so trivial to be insignificant, I'm not too worried about it, but it could be a little more robust than that. So I'm going to suggest that rather than try to figure out where you might have just put in an input number tonight, go ahead and shoot me a copy of your spreadsheet. I'm actually fairly good at finding the inconsistencies of them that you may have just overlooked. And it's easy to, because we've only got like a million things going on here, right?
Just a million.
Just a million. No big deal.
So, okay. And then my next question is, how do you calculate CV0?
Oh, okay. So in this case, I'm using it shows here DG, so that's the dividend growth or Gordon growth model. And I'm taking the cash flow.
Are you trying to share your screen?
Oh, sorry about that.
I was like, am I still looking at something else?
Gosh, I'm so sorry. I've been acting like I've been sharing it for the last 10 minutes. Please excuse me. You should have said something. Always feel free to call me on the carpet, Heather. Okay, so what I was looking at was over here. I was looking at my calculation of WACC over here. And if I make this a little smaller without so many roundings, it's 9.4%, right? But it actually was a much different number. So as I was showing you where I think part of the problem might live, and it may be in the WACC here, or it may be in one of the inputs to WACC, I just don't know, but I'm happy to help find it for you.
Yeah, my WACC is a little bit different than yours.
Okay, so certainly it's in one of those calculations, but let's look at my continuing value here.
Okay.
So my continuing value is going to take the cash flow in the last year of my explicit period, but I'm going to grow that by my growth rate. So here I've got H22, which is this value. So it's my cash flow in the last year of my explicit period, and I'm multiplying it by 1 plus 4%, or my long-run growth rate. So here in my numerator, I've got effectively the cash flow in time 14, right? The cash flow in 13 times 1 plus my growth rate gives me the cash flow in 14. And then I'm dividing that by my discount rate minus my growth rate. So if our discount rates somehow are slightly different, then our continuing values are going to be slightly different as well. If you used this year's cash flow without expanding it by the long-term growth, it's also going to motivate a difference.
That makes sense.
Cool.
Okay, I will send you my worksheet.
Sure.
It's something definitely wrong with my WACC, but
And I will send you my bill. No problem at all.
sounds good.
Okay. Anything else, guys? Okay, well, you guys have a good night then, and I'll talk to you over the next few days, I'm sure.